message in WhatsApp. So what I will do, I will start from the last chapter, okay? From the last chapter, and then we'll go further to the last chapter, okay? And whatever the question you have, you can ask directly here. So let me show you the last chapter. I should go back and show you the last chapter. So the last chapter is graph, as you know. So we will start from graph, and whatever the question you have, you can ask me. 7, 6, 5, 4, 3, 2, 1, like this I will go. So let me you can see it properly. Tolab, tell me you can see it. No problem. Okay, great. So I will just go fast, and if you have a question, you will ask me there. Okay. So prepare with the question. Whatever the question you have, whatever the confusion you have, you can ask. No problem. So this is the chapter graph, the chapter number 7. So what is in the graph? First, about the definition of the graph. As you can see in the down, the definition of graph. So let me wrote it down. Also, the definition of graph. Okay, a graph is made of set of nodes called vertices and a set of lines called edges that connect the vertices. So up to here is enough. If the graph definition comes, this is called node or vertices, and this is called edges. Okay. So here and then what is undirected graph? When there is no tariq, you say undirected graph. When there is a tariq, there is a directed graph. For example, we say right now this is a undirected graph because there is no direction here. Okay. Once you put some direction here, this is called an directed graph. This is a
Okay.
directed graph. Okay. Let's move on. This is a way how you can represent a graph. Okay. I already tell you in the class also. Suppose this is a graph given. Suppose only this graph is given. So what is the vertices here? A, B, C, D. So you write A, B, C, D. In here it is written E and F because there is a two graph together. So E, F. If only one graph is there you will write only A, B, C, D. Then what about the edges? A, B, A, D, B, C, B, D. Up to here. And this is up to here. B, D, you can say that. Up to B, D. Okay. Up to BD, and I will remove the here. Okay. Then the directed graph also you can write like this. What are the edges here? One. What are the vertices? Sorry, 1, 3, 5, 7, 9, 11. Up to here. But then edges 1 to 3, 1 to 11, whatever here. Right. 1 to 3 and 3 to 1 also. Okay. Then 3 finish. Then go to 5, 5 to 9 and 5 to 7. Finish. 5 finished. Then 7 is no there. Now 9, 9 to 9 because there is a self loop. 9 to 9 and 9 to 11. Okay. So this way we can represent. You can see this example also the same way. Okay. No confusion. Okay, Tula. This is the way to represent it. Adjacent, I tell you the meaning of adjacent on that day also. When it is directly connected, we say this is adjacent. Like for example, if it is here, we cannot say this node and this node is adjacent because there is no direct path. If I make path like this, hada kalam adjacent. So adjacent to, this is adjacent from. Okay. Remember this, because we use this concept in the representation of the graph. Okay. Then what is cycle? What is connected graph? When you take up any graph that is one graph, it's called connected graph. This graph is a connected graph. Okay. And the number complete graph, if you remember, I explain you, if there is a path from every node to other node, we say this is a complete graph. This is a complete graph. Like for example, A, you can go to any node directly. You can see, you can go to any node. B, you can go from any node, no problem. So if the graph is a directed graph, the edges will be n into n minus 1 if the graph is directed. If the graph is undirected, then the edge will be n into n minus 1 by 2. You can check where n is the number of vertices. For example, here total number is 2, 4, 6, 8, 10, 12. You can count here. 4 is the number of vertices. 1, 2, 3, 4. So 4 into 4 minus 1, that is 4 into 3, that is itna ashar. Okay. Here 1, 2, 3, 4, 5. 5 nodes, so 5 into 5 minus 1 divided by 2. That become 5 into 4 by 2. That is 2 divided 2 ashara. You can count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total number is 10. Then weighted graph. If you put any number here, 50, 60, 70, this is called weighted graph. Okay. Let's move. Then this is an example given of the different cities and their distance between, like Austin, Dallas, Denver, Washington, Atlanta, Houston, and Chicago. After this, all definition is there in the one page. Go all the definition, because you need to solve the multiple choice question. Also, what is adjacent vertices, adjacent from, adjacent to, complete graph, connected components, connected graph, connected vertices, cycle, directed, disconnected, edge, graph, path, undirected vertices, weighted. All definition is one page. Just read it all, okay? Because it will also important for the multiple choice questions. Then the next is array-based implementation. Okay, there is a two method here you are going to study. I tell you, if you remember, one was the adjacent matrix method and one was bucket or chaining. Okay, so in this method, I already tell you how to draw the graph. Any confusion here? This adjacent matrix, adjacent matrix. Any confusion here in this method? Kalam. Remember, Kaftarika, I tell you. Kalam, any confusion here? How to draw this? How you can make this one? Tell me. How first you write all the name in the order A to Z, okay? And then if there is a distance given, direct tariq maujood anta uktub hina. If not tariq, just write 0, 0, 0. Up to here only in your book. Up to here it will work. Okay? Up to here. No need to write this one. No need. Okay? Okay. Let's move next one. Then the second method was the link method, or we say the chaining method here. See, adjacent list method. This is okay. Adjacent list method is there. Sorry, I was just confused with the other thing. Okay, this is adjacent list method. Okay, so one was adjacent matrix and one was adjacent list. So in the adjacent list, nothing you have to do. Just if there is a point from Atlanta to 800, 800 means 5. 5 is what? Houston. Then you have to add other also here, like this. If there is a tariq from A to B and A to C, A to D, then you will write A to B, then C, then D, like this. You will make an adjacent list. Sah? Tola, faham this? Ada adjacent list method. Second method. For all adjacent matrix, बाद में adjacent list. Faham ada? Kalam. Kalamitullah. Okay. Then the last one was the chaining. Okay, the same method, adjacent list. Okay, it's not a problem. Bucket or chaining, where is? What happened? Bucket? I missed somewhere. Look, you don't do this method, bucket or chaining? No? Adjacent list, adjacent list. Okay, there is a two. Kalam ya Adam. Oh, sorry. Oh. That I was discussing about the hashing. Yeah? That's why I'm saying bracketing. Okay, here is a two method, adjacent list and adjacent matrix. Two method you have to remember and you have to do that. Yeah, that is a bucket chaining in the hashing. I forget that. Okay. Sometimes the mind has some sort of confusion. Okay, here is the two. One more thing, that was the DFS and BFS. In the last one, I already tell you how to find the DFS. You have to remember the algorithm. If come in the exam, you need to write the algorithm. This is the algorithm for DFS. Okay, and other, I will take one example for the DFS and BFS, and this is the example. This is the algorithm for BFS. So, lab DFS and BFS. Okay. This is the algorithm for BFS. Now, one graph I will take and I will show you how to find the DFS and BFS, and that's finished. So in this chapter, what you have to remember, the graph definitions, adjacent matrix, weighted graph, connected graph, disconnected graph, complete graph, weighted graph, all this definition, and the two method, adjacent list and adjacent matrix, then BFS and DFS. So I take one example again to show you that how to find the BFS and DFS. Okay, because I teach in the last, many students were not there that time. Right now also there is only 5 students. I don't know why they don't join. No problem. I think they are not interested. Okay. Okay. No problem. I forget. Okay. So let me share the whiteboard now for you. So this is the whiteboard and we have to show you the BFS and DFS. Suppose I'm taking any graph. I'm taking a random graph. Okay. The graph can be directed or the graph can be undirected. Okay, so it's not fixed. It's up to you. A, C, E, F, G, H. For example, this is a graph, and we have to find the BFS and DFS for this. Simple. Why I'm telling you, it is not very important. I'm telling you only thing because it is very easy. Okay, it will not take more time. Otherwise, I will take any example. Okay, so BFS. So you can say this is in the alphabet order. So I used to take the alphabet which comes awal in the order. So here we can see that A is the first order. So I will start from the BFS A. Now, you know that the BFS use Q and the DFS uses stack. So I will make one Q here. I will take one Q here. So first is in the queue, and we know that the BFS follows Q, and Q is nothing but first in, first out. Awal EG, awal row. So from A, I can go to C and I can go to E. So in English order, C comes awal before E. So I will take C and E. Now you can say I take C and E. Now you can see A adjacent are finished. So you can remove A from the Q. Now, what is the next node now? Next node is C. Let's check the next node, C. Where is C? C adjacent is F, A, and G. A is already finished. You can see here. A is finished. So, Bagi now F and G. So, in English order, A, B, C, D, E, F, G. So, F I will take and I will take G. Now, you can say C is also finished. And here you write F and G. Next node is E. E adjacent are H and F and A. A is already finished. F is already finished. Bagi H. So Uktu Bechina. Okay, I'm writing in the line. Okay, don't worry. It is not down. It is a straight line. Okay, because there is no space from writing down. H. So E is also finished. Remove E. Next node is F. F adjacent is G and H. Okay, G and H. So G is also finished. H is also finished. Remove H. G adjacent is only F and C. That is also finished. So this is our BFS. A, C, E, F, G, H. Any problem? Tolab, any problem? Yeah, this is undirected. Yeah. This is undirected. BFS finished. Okay, come to DFS. In the DFS, we use stack. I tell you many times. So the first, because in alphabet order, so I will take A as alphabet order A. So A is in the stack. So what is the rule in the stack? Last in, first out. Easy akhir row oval. Okay. So A is the akhir, so it should be oval now. So A I can go to E, I can go to C. But in English order, C comes oval, so I will take C. Now again the same rule, last in, first out. What is last in? C. So I have to take C. C I can go to F, I can go to G. So in English order, E, F, G. F comes oval, so I go to F. Again, the rule is same. Last in, first out. Last in is F, so I have to check F now. F, I can go to H, I can go to E, I can go to C. C, E, H, G. E, F, G, H. So E comes oval and C is already finished. So I will go to E. Now in the stack is E. Again, from E, I can go to H, I can go to F, I can go to E. A, F is finished. So now is Bagi H. Okay. H is finished. So H is now in the stack. Now again, last in, first out. What is last in? H. H I can go to F, I can go to E. F and E is already finished. So remove H. Next is E bagi. From E I can go to F, A and H. F is finished, A is finished, H is finished. Remove E. From F I can go to G, I can go to C, I can go to E, I can go to H. C finish, G bagi. H and E is finished. So I will take G. F is finished. C, F, G, A, F, G, A. Kullo finished now. A, kullo finished. E, C. So now this is your answer. A, C, F, E, H, G. No problem? No problem. Okay. So this is about chapter number 6. Read it everything carefully, whatever you get in the chapters. Read everything, okay? Because any question can come, so you should make the revision. Okay, let's go to the back and let me share you. Chapter number 6 now. Chapter number 6, hashing. See, Tulab, because there is only 5 students. See, if you have any question, you can ask, because I don't think it's very important to revision, make all the chapters. Kalam, any sawal, if you have, tell me. Kalam. I will go to direct that question because there is only 5 students. You know that? So I think the students are not interested. Any sawal, if you have from any chapter, Kalam, I will reply. Any confusion you have, tell me. I will go directly there. Postfix expression. Okay. I will go to the postfix expression directly. Yeah, I understand. Chapter number 3 is stack. Chapter number 3 is stack. Let me go there. Make revision all chapter 1 and 2 and 3 and 4 every, okay? Because sawal can come from any chapter. Oh, no, this is not. Wait, I'm going to there, stack. Yeah, I got it. So this is an example of a stack, how to find the postfix expression, okay, in the stack. So this was the example of getting the postfix expression. As you can see now, how we can use the stack to find the postfix expression very easily. Very easy method is there. I will tell you that method. Okay. Let me go back there. This example I'm going to take. This example. This is a good example. For example, this I'm going to take. Okay. Okay. you have to evaluate what is the expression here? 5, 7 plus 6, 2 minus Tulab Shuf. 1 minute. You have to evaluate 5, 7 plus 6, 2 minus multiply. This you have to evaluate as a postfix expression, means you have to evaluate using the stack. So you have to make one stack first. Okay, what is the first number from the left? 5. So you will put 5 number in the stack. Okay, this next number is 7. This all are the operand. Okay, 7, no problem. Next number is plus. Now when any operator will come, plus, minus, divide, power, anything come, then you will do the operation. So first number come 5, then comes 7. Now when the plus will come, you have to make the jama. Okay, the third one is the plus. Now the plus comes, then you make a jama here. So this will become 5 plus 7. Come Ada? Itnash. Now in the stack is itnash. What we have a stack in the itnash. So just remove this. 1 minute. I have to take the eraser. I will write here now itnash in the stack. Sorry. Drawing itnash in the stack. Okay. So 5, 7 plus finish. Now 6. Put 6 here. No problem. 2. No problem. Again minus. Again there is a minus. So what? This minus will come in between. So now 6 minus 2. 6 minus 2. How much it is? 4. So the next is now 4. So in the stack is now awwal hada itnash, now but 4. Okay? Minus finish. Now what is next number is multiply. Multiply. So again, if the multiply come, this will be between 12 into 4. How much it is? 48. Now this is the answer. Ash mushkil aada? Sahel, eh? Okay, good. So just practice this one. There is some more example. Easy. This is the easy method. You can see they did like this. Okay. So inshallah you can do it very easily. Just do some practice. Okay, 1 or 2 example is there. Just do some practice. Now ask me any other sawal, kalam. Kalam Tulab. Any problem, kalam? I will go to directly. Difference between binary and AVL tree. Good. I think you didn't ask the question directly. The question should be the difference between the binary search tree and AVL tree, or binary tree on AVL tree. What do you want to ask? Kalam. BST. Yeah. Okay, no problem. I'm give you the difference of everything. Give me a minute. 1 minute. Tulab, just give me 1 minute. One minute. Okay. Tulab, now. So there is a question. What is BST and remove this eraser. Why I'm taking this one? This is taking more time. Wait. I can do anywhere. Okay. This space is good because I need a space only. So the first question was, what is binary tree? Okay, Tola. First binary tree. A binary tree is a tree which have maximum 2 children. Maximum means maximum 2, but it can be 1, it can be 0. This is also a binary tree. This is also a binary tree, and this is also a binary tree. No problem, Tulab. But if I make like this is not binary tree. So, easy. Any tree which have maximum 2 children can be binary tree. If it is more than 2, then it is not a binary tree. Clear? Clear, Ada? Okay. Now, let's move to the binary search tree now. Binary search tree. Again, binary. Binary means again, there will be 2. The children will be 2 maximum. Okay. A tree is said to be a binary search tree, and in the short form, we say BST. Binary search tree. A tree is said to be a binary search tree if they have maximum 2 children. And again, the root node should be equal or less than the left child should be equal or less than the root. That means if it is 20, this can be 20 or 19 or 18 or 1, no problem. It can be equal also. The left node should be equal or less than the root. The left node should be equal or less than the root. So it can be 20 or it can be 19, 18, 17, 1, no problem. So maybe I can take Ashara. And the right node should be greater than 20, not equal here, greater. That means it should be at least minimum 21. So I take here 30. And this should follow from Folk to Tahat. Not only here, because now this Ashrin is in the left side, so all number will be less than Ashrin, Lazim. And here is Ashara, so Lazim, the number should be left should be equal or less than the Ashara. So this may be 5. This may be maximum 10. 10, I mean Kabir, Lazim. So, but it should be less than 20. I can take 19, no problem. Okay? This is a binary search tree. Confusion clear? Kalam. Kalam, any confusion AVL tree now? Binary search tree. Any confusion? The left node should be Sagir or equal to the root node, and the right node should be Kabir than the root node. Alatul. Now the condition comes about AVL. AVL, the name of the 3 person. First condition, it should be binary search tree. For the AVL, first condition is it should be binary search tree. If it is not a binary search tree, it cannot be AVL. Sir? Any problem? Second condition. The balance factor of any node should be less than 1. Should be less than 1 means it should be less than or equal to 1. Less than or equal to 1 means it can be 0, it can be 1. It can be 0. The difference, see, the difference means always you will make the Kabir minus Sagir. Means always the number will be positive. The difference, try to understand the difference. Difference means always Kabir minus Sagir. Sir? Now, see the example. Suppose this example, I want to check this tree is a AVL or not. How can I check? Balance factor of the 20. 1, 2. Maximum number of edges. How much? 2. Balance factor of the right, 2 minus 1. Come Ada? Wahid. No problem. 10. Balance factor of the SR 1, write 1. 1 minus 1, 0. Balance factor of Talatin, Hada leaf node means Hada 0. 0 because there is no left, no right. So 0 minus 0 is 0. Same here, 0. Same here, 0. Now, here you can see the balance factor is 1, 0, 0, 0. So this is AVL. Hada AVL, no problem. Faham? Faham Hada? Now, I will take one condition where there is no AVL. Suppose I am taking this example. Very small example I'm going to take you to understand. And this is 20, 10, 5, 3. هذا AVL ولا ما في طلاب؟ 20 10 5 3 هذا AVL ولا ما في؟ كلام هذا AVL ولا ما في؟ في AVL ولا ما في هذا نمبر 20 10 هذا AVL. Okay, and right I take one number here 30 now. This tree is a AVL, sorry, BST. Sorry, I'm talking not AVL, the BST. Okay, this tree is a BST, you know that. But we want to check this is AVL or Lamafi. So suppose here is Arba'in, for example. Now I want to check this is AVL or Lamafi. So I say AVL. For AVL, there is a two condition. One condition is the tree should be a binary search tree, and the second, the balance factor should be less than equal to 1. It should be 0 or it should be 1. The difference should be 1. Now let us start checking the balance factor of Ashrin. 1, 2, 3. Yamin. 3 minus 1, 2. Come on. Wide. No problem. Ashara. 1, 2. And Yamin hada 0. 2 minus 0. Come on. 2. 2 hada mushkila. Because it is more than wide. So you say directly hada, no need to check other node. Not AVL. Any node not following this is not AVL. Now kalam. Faham hada confusion? Tulab kalam. Now, any other question, Kalam? Kalam, any question you have, any chapter, Kalam? I will go directly. Collision linear proving. Okay, let's go to the collision linear. So I already tell you there is a two method here. One is the linear proving, and another is the chaining or bucketing. Okay, so that is chapter number 6, I guess. Yeah, chapter number 6. I will go to the chapter number 6 directly. No problem from the book. It's very easy to go. So I will show from the book. I will share the screen with you. 1 minute. Because from the book it's very easy to go there. Okay, so let me show you the screen now. Falab, you can see my screen, I think. Now you can see I open hashing there. So you are asking about the linear probing. Okay, in the first of all, the collision means from one space more than two data want to enter, or simple there is one space and more than one data want to enter on that particular space. So this is the example of the linear probing. Now, what happens in the linear probing generally? Suppose 20 modulo talata. I already give you the example how to calculate this. So 20 modulo talata is how much? Itne? Wala talata. And suppose there are number and we want to store that number in the order, in the table. Okay. Here is some problem. I know that. This is the table we have. Suppose here is 7 number. 4, 5, 1, 2, 3, 4, 5, 6, 7. Wait. because I'm not teaching online. That's me a little bit it's taking time. Wait. Again. So 0, 1, 2, 3, 4, 5, 6. Again, I'm telling you, if the function is given in the exam, you will use the same function, okay, compression function, or if not given, then you will count the number of terms, okay. If it is given, use the same. For example, now here, suppose there is a eraser. Let me erase this one. I don't want to keep this one. And drawing pencil 20 modulo saba. So lab, how much? 20 modulo saba come on. 20 modulo come 6. Very good. Very good. So it is 6 number. So what I will do, 20 you will put in the here in the screen. Okay. 1 minute. This is your 20. Khalas. Okay. Now the next number is, suppose next any other number we can take. I take 14. 14 modulo saba. How much? 14 modulo saba comes 0. I think 0. 0. So I will put here 14. Okay. Suppose now if we have 51. I'm taking a random number. How much it is? Okay. You calculate, it will do, no problem. So 51 is here. So it is 51. Sometimes there is an issue in the writing because of the pencil. Uh, $51. Okay. Now suppose there is a number is here is for example 16. 16 modulo saba kam aada. How much? 16 modulo saba kam itnain. And itnain is a collision because here is already one number is there, collision. So what you do, you will go to the next number. So you will write here 2 plus 1. See, I already explained in the class, and every time I already tell you to take the picture. So you can see there how I calculate. 2 plus 3 modulo saba. Kam aada? Talata modulo saba. Talata modulo saba means here. So here you will put your 16. Okay. If here also there is a collision, then 3 plus 1, 4 here. If here also collision, then here. This one, and if here is also collision, then you go to up here. This is one of the simplest way of the linear proving. Now here, if I am here in the linear also, you have to remember also bucket also. Practice both. Linear also, bucket also. Okay, this is collision by bucket. Same thing, just no problem. If there is a collision, just add with the other number, no problem. Like linked list. Okay? You need to know how to calculate the modulo. If you know, wallah, ada easy. If you know, ada easy. Sa? Tola, faham ada? Kalam. Who asked this question? Umar Hamdi. Okay. Whoever. Tola, faham? Kalam, any sawal? Which example? See, in the chaining, what you have to do, suppose there is a Suppose the first number come in on where? In the one position. Khalas, the number come in the one position. If second number come, you will add this number like this. Second position. No need to go to next. Just add the second number here. If there again if the same number come at 1, you will add here. Only you have to do it. Nothing different. Third position the number come EG. Second number again comes 7701. Maafi rota hai. Go again connect with this one number. Okay. Nothing different. That's why I'm not explaining it. It's very easy. Kalam tulam. Next one. Yes, start from 0. Every time 0. Every time 0. Don't confuse. You need to start from 0. The table size should be 1 less than. Okay, if there is a 7, if it is modulo 7 means 0 to 6. If it is modulo 13 means 0 to 12. If it is modulo 19 means 0 to 18. Lazim. Kalam tulab. Sawal Tani. Kalam. Okay, no problem. See, if you want to study, no problem. I'm giving you time. Tomorrow also you want to ask me some questions, send me in the WhatsApp in the group. I will reply you. Okay? Study hard, study everything, study from chapter 1 to 7, start from Akhir chapter, then go to chapter 1. So, make revision everything. Any confusion, send me the message in the WhatsApp. Okay? I'm not going to waste your time. Just prepare for the exam and all the best for the exam. Okay? Take care. Any sawal you can send me there. Kalam. Khalas sawal? Okay, study hard. Take care. Okay. Masalam.